In this video, we're asked to write a method called reorder that'll look through a linked list and it'll reorder all of the values based off of the absolute value here. So, for example, we have this list 0 minus 3, 3 minus 5, so forth, all the way to that. And it reorders it by absolute value, and as you can see, this is the proper order of dealing with whole numbers here. So we do have access to the front of the list. We have access to the data field and the next field. We're not allowed to use any sort of auxiliary data structures, such as arrays, array lists, queues, stacks, strings, so forth. So, but that's not going to be hard. It's because we're just going to do list node programming here. So let's get started. So, pull this back up. There we go. Okay, so what we're going to do is we're going to say, okay, it's going to be void because we're not actually returning a new list. We're just kind of reordering the whole linked list here. So it's going to be reorder. So what do we want to do? What happens if the front is equivalent to null? This implies that we have an empty list. And this implies that we don't have anything to reorder. So we don't need to do anything with that case. So we actually need to look at the interesting case as to when the front is not equivalent to null. Okay, so what are we going to do? We get through the list with a temp value, or we get through it with a pointer, more specifically. So we're going to create a reference to the front of the list. We're going to call it current. It'll point at the current value. So we're going to look to see while the next value of current is not equivalent to null, then we want to do some interesting things. Okay, so what happens if the data is less than 0? Well, at that point, that's when we want to start make our changes. And it'll become self-intuitive in just a second here as to what we're going to do. So our current.next field .data, if that happens to be less than 0 here, then we want to actually store some of the values so that we don't actually skip over a node and lose the value of it permanently. So this is a good point to create a new pointer, which we'll call the temporary value, and it's going to store the current.next value. So what we're going to do now is we're going to set current.next to point over current.next.next. The reason why we're doing that is because if we look at the spec here, when we're doing our little bit of reordering here, and we hit, say we hit the -3, we want to remove the -3 from this list and have front point at -3 and then have the 0 point at 3. So we want the next field here to point at the .next right here, if that makes a little sense. The next thing we want to do is we want to set the temps next to be equivalent to the front. Then we want the front to be pointing at that temporary value. And that will do the little bit of organization for us whenever we hit a negative number. And what are we going to do in the else case? Well, in the else case, we just want to kind of make our way through the list. So we'll keep running through this list until all of the negatives are on the other side of the 0. So meaning that they're at the front of the list. I forgot to mention something here. Just gotta close all these brackets. I forgot to mention something. What about specific ordering? Like, doing this will clearly not order a list that... It won't order a list that has the values 0, 2, 3, -5, or 5, -3. Because what it'll end up doing is when it organizes this list, it'll bring it in such a way. It'll look at the whole list. It'll say, okay, -4 is going to be at the front, then 0, then 2, then 3, then 5, then -3. Then it'll go through it again and it'll say, okay, -3, we need to move that to the front. So it'll say -3, -4, 0, 2, 3, and 5, which is clearly not what you expect. But I forgot to mention something in the spec here. And the spec said, notice the values are in sorted order if you ignore the signs. So this is already under the assumption that that the list is already in a sorted order. Yeah, so we're assuming that it's already sorted by absolute value. I hope that clears up things.